Hey everyone, welcome back. So this one is going to be our third video in our series for Arduino. We're actually going to be featuring a temperature sensor in this small project. So we're going to go ahead and build this thing and then program it. Let's go ahead and learn about what these temperature sensors do. So the first thing we need to do is click on create new circuit. And of course we're using Tinkercad, and if you're not familiar with Tinkercad, I highly recommend making an account. And I'm going to go ahead and name this, and this one's going to be called, this one's project 3 for me, and this one's Love-O-Meter. Okay, this one's going to actually be featuring a temperature sensor. Okay, so I need to go ahead and twist this thing. This is an Arduino. I'm going to zoom out a little bit. And then we get our breadboard. I'll be twisting that as well. Make sure they're kind of lined with each other. I'll put a little bit of space. And then we need 3 LEDs. These ones are going to be going into pin 19. Pin 22, and pin 25. And then we also will be needing a couple of 3 resistors. And these will be 220 ohm. I'm going to turn these as well. And these ones are going to be going into our negative. And this one is also on line, this one's on 20. I'm gonna copy, and this one's on 23 and 26. So we're gonna be sending power into 19, which is in the anode, out the cathode, into the resistor, then into ground. Before I do the 5 volts and the ground connections, let's go ahead and add our star of the show, which is the TMP36. So this temperature sensor is pretty popular. It's very common. You probably get it for like $2. Usually they sell them in packs of 5 or packs of 10. They're fairly cheap, and you can get them on Amazon or pretty much any electronics place. And they're used for pretty much everything. I mean, you can use them for thermostats. You see them in air conditioning units, you see them in amplifiers. I mean, you name it. If it's measuring temperature, this is probably it. And this one, it actually measures when in Celsius. If you want to be working in Fahrenheit, you need to do some conversions. But this one has 3 pins. Of course, it has the main power, so we'll be sending 5 volts inside here. And then we have, of course, the ground. And then the middle one is the voltage output. This one's on pin 5. So what's going to be happening is this one is going to be measuring temperature, and based on what the temperature is, it's going to be sending a voltage out, and we're going to get a reading. It's an analog output, so we're going to actually be connecting an analog AO here. We're going to be doing some programming to do some conversions and then manipulate the LEDs based off of that. So let's go ahead and get our voltage, 5 volts into positive, and then our ground to negative. Okay, and of course I want these color coded correctly, so we'll do red. Our ground is black always. And then we have pin 5, that one's also positive, so it's red. And then our ground, pin 7, black. And then we can do our analog connection to pin 6. And I'm gonna line it up here. I'm gonna click here first, so it kind of looks a little neat. It's not perfectly straight, but it's close enough. So what's happening is, remember, we're having voltage coming in, temperature sensor is going to get a reading, and then based off of that reading, we're going to have an output signal, then we're going to read that, and then we're going to manipulate the code with that signal. So, and of course, then we're going to want some outputs. So we're going to do pin 2 into 25 here. We'll do that yellow. Pin 3 into pin 22, and then pin 4 into pin 19. Yellow. Okay, so our wiring is done. We have, like I said, we have 5 volts coming in. 5 volts are going to come into our input. Ground's connected to ground. And then our signal is going to come in here. And then our processor, based off of our programming, we're going to do some stuff. And then we're going to make these LEDs light up based on the temperature reading. All right. So if I click start simulation, nothing's going to happen. So we have to program it. So let's go ahead and jump to programming. So you click on code. And if you want to code this thing inside blocks, you can, but you know, learn text as soon as you can, right? So I'm going to delete the default code that's on here, and we have a couple of constants. So our first constant is sensor pin. Sensor pin is going to be A0, and of course that's always going to be connected to A0, so that's our first constant. And anytime we're referencing sensor pin, we're going to be referencing A0, okay? And then our next constant is baseline temp, and this is kind of just a baseline temperature, and you'll see what we're going to be doing with that a little bit later on. So these are our 2 variables. They're constants, so they're not going to change at all throughout the entire program. Okay, the next is our void setup. So in here, serial begin. And what this one does is it actually opens up a serial port, and then we're going to do a for loop. I'm just going to go ahead and put the rest of this code in, and then I'll be explaining exactly what we're doing. So pin mode, pin number, output. I'm going to put a comment here. So this is going to close our for loop. A lot of typos today. Okay, so what's going to be happening is, so our serial monitor is going to be reading out information. That way, you know, down here when we run the program, we'll be able to know exactly what's going on before we send it to the LEDs. Okay, so let's go ahead and close this up. This one closes the void setup. I'm just putting this for reference for you so you don't get lost. Sometimes people get lost with all of these wavy brackets, right? So next one is our main program inside of our loop. We don't have any arguments, so let's go ahead and just get started. We have a variable, integer, sensor val, and that's going to be getting analog read sensor in. This is the variable that we're going to be storing the information from the analog input. So the analog is going to be sending it into pin A0, and sensor value, of course, will store that value. Okay, so the next thing is serial print. Got a syntax there. You got to open and close it, and a semicolon. And then we're going to serial print the value. Okay, the next thing is we want to convert the ADC reading to voltage. How do we do that? Float voltage equals sensor val divided by 1024.0 times 5.0, and then serial dot print, comma, volts. Next line, serial dot print voltage. So this one's going to actually be printing the voltage right after that text volts. Okay, after we print that, next we're going to print degrees Celsius. So serial print, I'm going to put a comma, space, got to put the parentheses, locations, degrees C, and then convert to degrees. comment. Next line, float temperature equals voltage minus 0.5, close parentheses, times 100. And then serial dot print line. This one's going to be different than the other. So instead of it being just in one long line, you need to put print line, and it'll at the end of that statement, it'll add a new line. Okay. So all this information is going to be in one line, and then it's gonna read. So the next one is temperature. Let's close it. Temperature. Close that. Okay. So let's see what we got so far. So far, we're not controlling the LEDs yet. But let's see if we have any problems inside here just using the serial monitor. So I'm going to start simulation. And I have an error. And the error is probably above this line. So anytime you have an error, this is very good. I'm glad this happened. Anytime you have an error, it's usually not that line. It's usually the line before. And of course, I see it right here. I'm missing parentheses. Let me try it again. Start simulation. Boom. Okay, so it looks like nothing's happening, right? But if you click on serial monitor, I'm getting some readings, right? And I'm going to move this over a little bit so I can control the thermostat. You can't really see it. I'm going to stop simulation real quick. I'm going to move this over just a little bit. Start simulation again so I can mess with this temperature sensor. Okay, so here we go. I'm getting a value 153.75 volts. And then degrees are 24.71. So if I click on this, obviously, it's a virtual environment. You can actually manipulate, how much temperature you want. So if I max it all the way, I'm getting a measurement of 124.80 Celsius. And that's getting a sensor value of 358 and volts of 175. And then the minimum 20 sensor value, volts 0.1, and then degrees Celsius negative 40 degrees Celsius. I mean, that's pretty cold. So this thing is accurate within 2 degrees Celsius, plus or minus. And of course, the closer it is, I think it's to 20, 24. I don't know. You have to look up the closer it is to the midpoint, it's actually within 1 degree. So it's a pretty cool sensor. I mean, either way, 2 degrees is pretty close. So I'm going to stop simulation, and we're going to go ahead and program the rest. I'm going to lower serial monitor real quick. And next thing we're going to add is the code for the LED. So I'm going to add a space just for the meter controls LEDs. Okay, temperature is less than baseline temp. This is where the constant baseline temp comes into play. And then open wavy bracket, digital right. We have a lot of similar lines, so I'm going to be copying and pasting a lot here. 2 low. All right, so I'm going to copy this line, and I do this all the time with my code. I just copy and paste, and this is going to be 3, 4. So they're all lows, and else if temperature is greater than or equal to baseline temp plus 2, and temperature is less than baseline temp plus 4, and then I'm going to copy these lines. So what's happening is if the temperature is less than the baseline temp, meaning 20 degrees Celsius, if it's totally lower than that, all the LEDs are going to be low. They're going to be pretty much off, right? So we need to change that to high. So what's happening here is if the temperature is greater or equal to 22 and it's less than 24, because it's temperatures less than or equal to, no, it's just less than. If it's less than 24, so it's between 22 and 24, then you'll have one of them high and the other one's low. I need to close that. We're going to do our last else if. I'm going to copy this. Be careful when you copy, because sometimes you make mistakes. So I have an open parentheses. I got to close it. And this one is the next step, which is, 24 and 26, so it's within there. I'm going to have high, high, low. And I'm going to copy this entire thing. And then the last one will be high, 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 right? But it's going to be if it's equal or greater than temp6. So let me delete all this. Let me widen it so you can see all the rest of the code. So that's what it looks like. I still need to finish it up a little bit. Close the wavy bracket here. And the last thing I want to do is I'm going to put a delay 1. And let's see if we got this correct. Let's see if there's any errors. Okay, so our serial monitor is doing its job. So I'm gonna close the code here, and I'm looking at this, and I'm seeing that it's kind of hard to read. So I'm gonna move this over a little bit. I'm gonna open up the serial monitor. So right now I'm getting a reading of 46 degrees Celsius, or actually 47, right? Okay, so right now I'm getting a reading of 24 degrees Celsius. So if I increase it to 26, 28, oof, it's very sensitive. 28 is obviously greater than 26, right? Now I'm on 16, it's very sensitive. 24, so that's right here. Let me see if I can click it to get to 22. So you can actually play around with this. If you don't want it as sensitive, you can actually change these parameters around. So if I wanted to put baseline, I'm going to put this +5. I need to stop programming. So if I want to change this +5, and of course put 10 and 20, and of course 20, right? So if I have this, it's not as sensitive, and maybe I can actually get some better readings. I'm going to hit simulation. Right now it's 24. So in order for it to be low, it's going to be less than 20. And right now it's at 52. So all of them are high. So 20 plus 20 is 40. So 40 is my max. I think if I can get to 30, there's 30. That's the medium. Wonder if I can get to 25, 28. That's within my medium. So all three of them work. All three of these sections work. So there you have it. I mean, thank you guys for joining the channel. Please click subscribe. I'll be throwing out some more of these videos pretty soon. I have plenty of these projects that I'm going to be working on, and I'll be recording them. Please play around with Tinkercad. This is such a great application. You can mess around with so many different things. You can make your own little devices, purchase an Arduino, and then build it physically. So this is great to test, great to do whatever you need to do, great for small projects. Until next time, I'll see you guys